Okay, thank you for being here. Today I'm going to tell you about a new test set we've come up with for detecting latent gender bias in coreference resolution. Coreference resolution has already a history as a test bed for detecting gender bias. For example, we have SoWinoBias created back in 2018. And for those who may not have seen it, it goes like so. So for example, if we look at the first sentence, the physician hired the secretary because she was highly recommended. The correct resolution is to say that she refers to the secretary. But we can also notice that this aligns with a social stereotype. Now, in the second sentence, all we've done is switched the gender pronoun. So we have the physician hired the secretary because he was highly recommended. Again, of course, the correct resolution is to say that he refers to the secretary. However, this now opposes a social stereotype because the physician is a more male-coded occupation compared to the secretary. So we can measure the overall gender bias of a model if it typically performs better on the first type of sentence. Now, SoWinoBias uses explicit or definitional gender vocabulary. So here we've used explicit binary gender pronouns, she versus he. The idea of SoWinoBias is that we want to remove all explicit gender markers and see if we can still find some latent or induced gender effects. So let's look at some examples of how this works. So example one here, the doctor liked the nurse because they were beautiful. Given the context, the correct resolution is to say that they refers to the nurse, where here they is like singular gender neutral pronoun. However, we can notice that this as well corresponds or aligns with a social stereotype, the nurse being a more female coded occupation versus the doctor being more male coded, as well as the adjective beautiful stereotypically being something that would be more likely to describe a woman. Now consider the second sentence where all we've done is we've switched the order of the occupations. So the nurse liked the doctor because they were beautiful. Again, they should refer to doctor, but this now contradicts the social stereotype. So again, we would measure gender bias in the model if it can typically have a higher prediction accuracy on sentences like the first one that align versus ones that contradict some stereotypes. However, all the sentences within the SoWinoBias test set don't use any explicit gender markers. Rather, the induction occurs because of some shared gender associations. In this case, we're using occupations as well as stereotypical adjectives. So let me explain a bit, why do we think this idea of observing latent gender bias is interesting right now? Well, for one, I think it's obvious maybe we should be aware that gender effects can happen even when there's no explicit gender markers present, and we would like some test sets for measuring that. But secondly, I think this is an interesting topic given progression we've seen lately in debiasing methods applied to word embeddings. So normally debiasing methods are motivated by noticing some intrinsic property of bias in the embedding space and then working to improve that property, right? So some of the very first debiasing methods, they were focused on this idea of direct bias. So they introduced the concept of a gender direction. And we can notice that any non-zero projection of a word onto this direction implies some kind of uneven similarity between the genders. So early methods like hard debias and gender neutral glove work to minimize or eliminate that projection. The next wave of debiasing methods seem to be motivated by this critique paper. So this is the Gonin and Goldberg paper from 2019. And they essentially showed how bias in the embedding space is really largely unchanged, even after direct bias mitigation. So they showed the existence of clustering and recoverability. And these together we can think of more as indirect measures of bias on the embedding space. And one method that partially addresses these things is the iterative null space projection method. Finally, another way that we could think about indirect bias on the embedding space is to quantify undue gender-induced proximities among word vectors. For instance, if we looked at the word vector for nurse and looked at some of its nearest neighbors, there are some that seem to make sense to be there, so things like physician, infirmary, but some that seem to be only there because of some sort of shared gender association. So things like sweetheart, receptionist, and so on. So this whole thing was formalized into a single metric called GIP, which measures these undue proximity bias. So we can see in recent years, there's been this progression of identifying bias from direct to indirect, and then developing the corresponding mitigation methods. One goal of our paper then is to design a test set that measures the presence of this indirect or induced bias, more so on a downstream application. So here we've chosen coreference resolution. So in the paper, we report performance on SoWinoBias of these 4 mitigation strategies I've mentioned. But in particular, we want to analyze their performance in the context of how they alter or how they aim to alter the embedding space as measured by these different intrinsic bias measures. So this is like the global picture or the theme of what our paper tries to address. To keep it brief, some of our key findings indicate that, firstly, the second order bias, it does seem more difficult to correct than the explicit gender bias. However, we did see some early methods, so ones that were more focused on the direct bias mitigation can perform well if they're paired with data augmentation. So in that case, we've observed that the mitigation of the indirect bias is not a necessary condition for doing well on SoWinoBias. Finally, we do observe that some direct associations among word vectors on our vocabularies of interest, so like the gender stereotyped occupations and the adjectives, they have a remaining strong association even in all of debiased embedding spaces, which is somewhat unexpected in those cases where the debiased embedding space was meant to have somehow mitigated indirect bias effects. So I think the overall conclusion is that there's room for reflection, I guess, on both how we measure indirect bias on the embedding space, as well as what's the expected connection to more observable bias in a downstream application. So if you're interested, please check out the paper or our GitHub. Feel free to contact me, and thank you for listening.